In this video, we want to integrate the cube root of x over the cube root of x minus 1. We're going to do this using two different ways. The first way, we're going to make a substitution. So let u equal the cube root of x minus 1. So the derivative will be 1 over 3 times x to the 2/3 power. Okay, so the denominator becomes u, but what happens to the top? Well, you need to figure out what cube root of x is and what dx is. First, let's work with dx. We know that du is equal to 1 over 3x to the 2/3 dx. So we'll multiply both sides by 3x to the 2/3 power. And now notice that u is equal to the cube root of x minus 1. So u plus 1 is the cube root of x. I want 3 times x to the 2/3 power. So square both sides to get x to the 2/3 and then multiply by 3. So now we know what dx is. Dx is going to be 3 times u plus 1 quantity squared du. So we know the denominator, we know dx. Now we need to figure out what cube root of x is. Well, cube root of x actually we have over here. U plus 1 is equal to cube root of x. So now let's put it all together. We have 3 times u plus 1 cubed du. Now, recall that dx has a u plus 1 squared, and when you multiply by cube root of x, which is u plus 1 times u plus 1 squared becomes u plus 1 cubed. And then don't forget the 3 from the dx, and then all over u. Okay, this step I factor out the 3, and then I expanded the u plus 1 cubed. Now I can break this up into 4 individual fractions, but notice that u cubed over q becomes u squared. 3u squared over u is 3u. 3u over u is 3, and then we have just 1 over u. Now we find the antiderivative of each of these terms. Replace u with cube root of x minus 1, and with some simplifying, we end up with this expression. So this will be the final answer. Now I did skip a couple steps here, but just know that this is the end result. Okay, now let's avoid using the substitution. Let's just use algebra. Well, what I'm going to do is subtract 1 and add 1. And the reason is because now, if I just look at the first two terms, those match with the denominator. So I'm going to break this up into 2 fractions. The first fraction is going to be the cube root of x minus 1 over the cube root of x minus 1. And then the second fraction is just 1 over the cube root of x minus 1. Now the reason I did this is because now this cancels and you're just left with 1. So it's 1 plus 1 over the cube root of x minus 1. I can split this up into 2 separate integrals. The antiderivative of 1 is just x. And now I just need to focus on 1 over cube root of x minus 1. Let's let u equal the cube root of x minus 1. Du then is just 1 over 3x to the 2/3 power dx. So this is similar to the first way we solved the integral. So multiplying both sides by 3x to the 2/3 power, we get 3x to the 2/3 du is equal to dx. We want to rewrite everything in terms of u. So again, we'll solve for cube root of x by adding 1 to both sides and then squaring both sides, multiplying by 3. So now I finally have 3x to the 2/3 power. That's just 3 times u plus 1 quantity squared, and then du. So I just solved for dx. I know the cube root of x minus 1 we said was u, so I have everything that I need. And I plug it in here. Now I factor out the 3, expand the u plus 1 squared. Now I'll break this up into 3 separate terms. We have u plus 2 plus 1 over u du. Find the antiderivative. Remember, u was just the denominator, which is cube root of x minus 1. And then with some algebra, you end up with this final expression. Note that this is the same answer as the first method.